Good morning, this is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today I am going to discuss about theory of matrices and linear transformations. First, we have to know the matrix and what are the types of matrices and how we can solve a matrix and how we can take the matrix order and dimensions and all we have to know in this session. First of all, we should know about the matrix. What is a matrix? A system of mn numbers arranged. Those mn numbers are either real or complex, arranged in the form of an ordered set of m rows and n columns. In between square brackets or open brackets is called a matrix of order m by n. So generally here we have mn numbers. Mn numbers are nothing but, suppose I am taking m are 2 and n is 3 elements numbers. M I am taking 2 numbers, n I am taking 3 numbers. Mn numbers, how many numbers? Mn nothing but 6 numbers we have to arrange in a square bracket or open bracket. The system is said to be a matrix. So I am taking any 6 numbers like 1, 2, 3, 4, 5, 6. So here I am taking m is 2. What about m? M indicates number of rows. In this set, how many rows? We have 2 rows. One first row and this is second row. So first write the rows. How many rows are there? First write row number. And next we have columns. How many columns? Here we have 1 4 is 1, 2 5 and 3 6. These are 3 columns. So write columns in the next one. So 2 into 3, nothing but order of the matrix. We read like 2 by 3 ordered matrix. In the matrix, we have real numbers or complex numbers. So now we have to know general matrix form. What is the general matrix form? So here we have 1, 2, 3, 4, 5, 6 elements. Now we have some order of the 1. What is the indication of this one? A11. A11 is nothing but first row and first column value. First row, this is first row and first column value. Similarly, the second value indicates A12. A12 is nothing but first row, second column value. And similarly, next one is A13. First row, third column element. Similarly, second row A21. Second row, first element. And second A22. Second row, second element. And third one A23. A23 is nothing but second row, third column. So like this we have to take the general order of that element. A11, A12 and so on, A1n. So here I am taking m rows and n columns. So here we have m rows and each row having n numbers. So like that A11 I am writing general indication. A12 is first row, second element. Similarly, last element is nothing but A1n, first row, nth element. Similarly, second row starts from A2, second row. First element means A21. So here we have A21, A22 and so on, A2n. Similarly, we consider here m rows. So finally, the last row is AM1, AM1, AM2 and so on, AMN. AMN is nothing but last element which is mth row and nth column value, AMN. So generally I am writing Aij m by n. I and j are indicated from I from 1 to m, j from 1 to n. I indicates 1 to m, m rows. First row, second row and so on. Similarly, m rows. I indicates rows and j indicates columns. So general matrix of the form Aij m by n. Here m indicates rows and n indicates columns. So any matrix, either real numbers or complex numbers arranged in a set of rows and columns, the system is said to be a matrix, which is either square matrix or rectangular matrix and so on. We have some types of matrices. So first we should know about the square matrix. What is a square matrix and what is a rectangular matrix? Square matrix is nothing but a square matrix A of order n by n is called n-rowed matrix or simply a square matrix. Nothing but in any matrix, number of rows and number of columns, if suppose equal, the matrix is said to be a square matrix. I am taking here 2 rows and 2 columns. So how many elements we have in that matrix? 2 rows means m is 2 and n is here 2. 2 by 2 is nothing but 4. Mn elements. How many elements in that matrix? We have 4 elements in that matrix. Those are I am taking 1, 1, 2, 2. Which is a square matrix. Here number of rows and number of columns are equal. And simply we can take this n-rowed matrix and go for the rectangular matrix. If both m and n are equal, the matrix is said to be a square matrix. If both m and n are not equal, the matrix is said to be a rectangular matrix. So I am taking m is here 2 and n is here 3. How many elements in that matrix? 2 3s are 6 elements we have to write. How we can write 6 elements? Consider only 2 rows and columns are here 3. So I am taking 2 rows and 3 columns. So those are like I am arranging 1, minus 1, 2 and second row I am taking 2, 3, 4. So I am arranging 2 rows and 3 columns. Total we have 6 elements or 6 numbers. So always we are indicating matrix as a capital letters called capital alphabets. So generally I am taking A. A is nothing but a matrix of order m by n, which is either square matrix or rectangular matrix. Now here third definition or third type of matrix is row matrix. What is row matrix? A matrix of order 1 by m is called a row matrix. 1 by m, nothing but the rows are should be here 1. Then we take the matrix is said to be a row matrix. Any columns we have one row. So here 1, 2, 3, 4. How many rows and how many columns in this matrix? We have only one row and columns are here 4. So this is 1 by 4 matrix. Then the matrix is said to be row matrix. In this we have only one row. So always in the row matrix, the first entry is 1 and n is here anything more than 2, 3, 4 or anything. So the matrix is said to be row matrix. Next we have column matrix. What is column matrix? Same like row. In the row matrix we have only one row. Nothing but order of the row matrix is 1 by n. Now the column matrix having we have one column and rows are anything, any number. So then the matrix is said to be a column matrix. A matrix of order n by 1. Here the column order is must be 1. Here rows are anything and more than 1 we have any order. So the column matrix order must be m by n. Nothing but in this we have only one column and rows are anything. Then the matrix is said to be column matrix. So the order of the column matrix is generally here we have 3 rows. So I am writing here 3 by 1. The column must be here only 1. What is the column matrix order in general? M by 1. M is indicates rows. Here we have to consider m rows, but column must be 1. So the column matrix order is nothing but m by 1. Similarly, we have unit matrix. What is unit matrix? If capital A equal to Aij n by n. Here number of rows and number of columns are same, which is a square matrix. So how we can take the unit matrix? Such that Aij's are 1 for I equal to j and Aij's are 0 for I not equal to j. Then A is called a unit matrix. So what is unit matrix? Which is a square matrix. First of all, why which is square? I am taking Aij n by n. Number of rows and number of columns are equal. So in any unit matrix, the elements are either zeros or 1. So where we kept 1 and where we kept zeros, we have the condition. That is Aij equal to 1 for I equal to j and Aij equal to 0 for I not equal to j. Then the matrix is said to be unit matrix. Generally, the unit matrix we indicate capital I. I of order anything, either 2 by 2 or 3 by 3 or 4 by 4, whatever it is, must be a square matrix. I2, just simply we indicate I2. Why? Which is I2? Which is a square matrix. So definitely equal number of rows and columns. I2 is nothing but 2 by 2 square matrix. In that we replace ones and zeros. Where are the ones and where are the zeros? 1 indicates in the diagonals and the remaining all elements are zeros. This is indicates A11 and next one is A22. Aij's are 1 where I must be equal to j and Aij's are 0 where I not equal to j. Here we have A12 and this is A21. A12 and A21 both are I not equal to j. So therefore here we have zeros. So in identity matrix we have diagonals are ones and remaining all are zeros. Now go for the zero matrix. What is zero matrix? In any matrix, all the elements are suppose zero elements. The matrix is said to be zero matrix. Identity matrix means at least we have A11, A22 are indicates 1. But in zero matrix, all the entries are zeros, which is either square matrix or rectangular matrix. We indicate zero matrix like capital O. O are the 2 by 3. 2 by 3 is nothing but 2 rows and 3 columns. All the entries are here. We have zeros, which is nothing but zero matrix. Next, diagonal elements in a matrix. What are the diagonal elements? Where A11, A22, A33 and so on, ANN. Definitely the given matrix is a square matrix and all the Aij's where I equal to j values are said to be diagonal elements. In any matrix, A11, A22 and so on like this. In the last we have ANN. All these values are said to be diagonal elements. So generally I am taking A equal to Aij m by n or n by n. Why? Because n by n. If we take diagonal element, then the matrix must be a square matrix. So Aij of A for which I equal to j. That is A11, A22 and so on. ANN are called the diagonal elements of capital A. For example, I am taking 3 by 3 matrix order. In this, we have 9 entries. 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the diagonal elements in this matrix? A11, A22, A33 elements are nothing but diagonal elements. Nothing but 1, 5, 9 are said to be here diagonal elements. So the line along which the diagonal elements lie is called the principal diagonal of capital A. The line, in this line we have the elements 1, 5 line. The line is said to be principal diagonal of A. Now go for the diagonal matrix. What is the diagonal matrix? A square matrix, all of whose elements except those in leading diagonal are 0 is called a diagonal matrix. Generally the diagonal elements are nothing but Aij's, here I equal to j values. But what is a diagonal matrix? In that matrix we have only diagonal elements. Remaining all the entries are zeros. What about all the entries? Other than Aij, I equal to j values. Nothing but A12, A21, A31, A13 and all these entries are I not equal to j values. So in a diagonal matrix, we have only diagonal elements and remaining all are 0 entries. The matrix is said to be diagonal matrix. We can indicate capital A and simply we write DIAG, diagonal of which elements? Diagonal elements. In this matrix we have 3, 1, minus 2 are diagonal elements. So we write diagonal matrix in a simple form DIAG of 3, 1, minus 2. Next we have scalar matrix. What is scalar matrix? What is the difference between diagonal matrix and scalar matrix? In a scalar matrix, we have only diagonal elements and those diagonal elements are equal. In a diagonal matrix, we have diagonal elements are not equal. In a scalar matrix, first of all, which is the diagonal matrix where the diagonal elements are all equal. For scalar matrix, first of all, which is a diagonal matrix whose leading diagonal elements all are equal. is called a scalar matrix. Definitely which is also a square matrix. Square definitely which is diagonal matrix. In the diagonal elements all are equal. Then the matrix is said to be scalar matrix. Now go for the equal matrices. When we say two matrices are equal, two matrices I am considering here, capital A equal to Aij and one more is capital B equal to Bij, are said to be equal if and only if A and B are of the same order or same type. Suppose I am taking A is order 2 by 3, B also consider as order 2 by 3 only. And what is the second condition? Aij, all Aij's are equal to Bij for all I and j. Then we say that the two matrices are equal matrix. For example, I am taking A equal to 2 by 3 order. Take any one. 1, 2, 3, 4, 5 minus 1. This is A matrix. 2 by 3 order. 2 rows and 3 columns. B I am considering same. What is the first condition? A and B are should be same order. Same order. If A is 2 by 3, B also consider as 2 by 3. So now second condition is Aij equal to Bij. Here I am considering A11, A12, A13 values. In the second row we have A21, A22, A23. Similarly, in the B matrix, all are having same elements like that 1, 2, 3, 4, 5 minus 1. Here Aij and Bij both are same. Then we say A is equivalent to B matrix. We say that A and B are equivalent matrices. First condition is order should be same and each and every element in A and B should be same. Then we can say A and B are equivalent matrices. Let's take transpose of a matrix. What is transpose of a matrix? The matrix obtained from any given matrix capital A by interchanging its rows and columns is called the transpose of A, and it is denoted by A dash or A transpose. So we write A transpose or A dash, nothing but interchanging of rows into columns. If A I am considering generally M by N matrix, which is either square or rectangular matrix. Then the transpose of A we can take A dash. I am taking Bji N by M. Order should be changed. We have to change rows into columns. That's why M by N will get N by M. Where Bji equal to Aij. Also, A transpose and all transpose will get again A. Interchanging of rows into columns, again interchanging of rows into columns will get again given matrix A. So, for example, I am taking A equal to 1, 2, 3, 4, 5, 6. What is the order of this matrix? 2 by 3. What is transpose of A? Change rows into columns. I am taking the matrix is A transpose. What is A transpose? First row change into first column. Second row change into second column. What is the first row here? 1, 2, 3. Now take that 1, 2, 3 into first column. First row become first column 1, 2, 3 and go for the second row. What is second row here? 4, 5, 6. Change 4, 5, 6 into second column. That is second row become second column. Now what is the order of A transpose? How many rows in this? 3 rows. And how many columns? 2 columns. So A is order 2 by 3 and A transpose order is 3 by 2. A is nothing but given matrix order 2 by 3. Then A transpose become 3 by 2. So here we have Aij M by N. Then we got Bji. What is order here? N by M. So order is here change. So transpose of A is nothing but interchanging of rows into columns. So if we take one more time transpose of this, A transpose, again whole transpose, definitely we get A matrix. Again change row into column. We'll get again 1, 4 is first column, 2, 5 second column, 3, 6 third column. Again we'll get A. So what is the property here? A transpose and whole transpose will get A. Similarly, A plus B whole dash or transpose. Anything, both are same. A plus B whole transpose equal to A transpose plus B transpose. And the third one is K is any constant. We cannot take constants to transpose. We consider only for matrices. If any matrix of the form K A whole transpose, K is as it is, we write A dash or A transpose. We have to change. K is here any scalar value. Now third one, AB whole transpose equal to B transpose into A transpose. Suppose multiply A and B. Consider any two matrices A and B. Multiply these two and take the transpose of AB. Then which is equal to definitely B transpose into A transpose. Consider B transpose separately and A transpose. Multiply B transpose into A transpose. Then you will get AB whole transpose value. So here we have property AB whole transpose equal to B transpose into A transpose. Now symmetric matrix. What is symmetric matrix? First of all, the given matrix is a square matrix. A square matrix capital A equal to Aij is said to be symmetric if Aij equal to Aj for every I and j. So thus if A is a symmetric matrix means A transpose should be equal to A. I am considering one matrix AHG HBF GFC, which is a square matrix. Why which is a square matrix? I want to take row into column. AHC become again AHG. HBF again second column HBF. Third row GFC become, here we have third column GFC. If we change rows into columns, we'll get C matrix. So A transpose we will get again A matrix. So the matrix A is said to be symmetric matrix. Next go for the skew symmetric matrix. What is skew symmetric matrix? It is also square matrix. Capital A equal to Aij. General order. Square property definitely, which is n by n, is said to be skew symmetric if Aij equal to minus Aj for every I and j. What is the difference between symmetric and skew symmetric? In symmetric, we have A transpose equal to A. If we change rows into column, we'll get same. But in a skew symmetric matrix, if we want to change row into column, we'll get A transpose equal to minus into A matrix, given matrix. Then the matrix is said to be skew symmetric matrix. So for example, I am taking 0 A minus B minus A 0 C B minus C 0. I am taking one example like this, which is a skew symmetric matrix. How which will be skew symmetric matrix? First take the transpose of that matrix. What is A transpose of this? 0 A minus B. Second row becomes second column minus A 0 C, and third row becomes third column B minus C 0. Now from this I want to take minus common. Then we'll get 0 A B minus A 0 C, and the third row is B minus C 0, which is again given matrix. If we take minus common, here we'll get minus. So 0 A minus B minus A 0 C B minus C 0. Again we'll get A matrix. So A transpose here we have equal to minus A. So then A is said to be skew symmetric matrix. Or we can write A equal to minus A transpose. Both are same. A transpose equal to A or A equal to minus A transpose. Then A is said to be skew symmetric matrix. Here we will observe one thing, that is all the diagonal elements in a skew symmetric matrix are necessarily 0. So here the diagonal elements are nothing but A11, A22, A33. All the entries are here zeros. In any skew symmetric matrix, all the diagonal elements should be 0. Then only we can find skew symmetric matrix. Here Aij equal to what? Minus Aj. Nothing but 2Aij equal to 0. Definitely Aij equal to 0. So all the diagonal entries are here 0. Now trace of a square matrix. What is trace of a square matrix? Capital A equal to Aij, general matrix, n by n order. The trace of the square matrix capital A is denoted by TRA. And we can take sum of all the diagonal entries. I and j must be are from 1 to n, j also from 1 to n. All the entries are here same. I must be 1 to n. So we can take sum of all the diagonal entries. What are the diagonal elements here? A, B, C. Trace of A is nothing but here A plus B plus C. So take the sum of the diagonal elements for a given square matrix. Trace of A is nothing but some element, some number. Sum of take diagonal elements. Now what are the properties of trace of a square matrix? If A and B are square matrices of order n and lambda is any scalar, we can write trace of lambda equal to lambda into trace of A. Trace of AB we can take A and B, consider two matrices, add both the matrices, take trace of these A plus B. Then we'll get definitely trace of A plus trace of B. And trace of AB is equal to trace of BA. Multiply AB or BA. Consider trace of AB and trace of BA. Both must be equal. So trace of AB is equal to trace of BA. Now here we have one more important definition, orthogonal matrix. What is orthogonal matrix? A square matrix capital A is said to be orthogonal if what is the condition? A and A transpose. If we multiply these two matrices, we'll get definitely identity matrix or unit matrix. What is I matrix here? In the matrix, only we have diagonal entry, those are ones, and the remaining all are zeros. First take the given matrix A, take the transpose of that matrix and multiply both A and A transpose, then definitely you will get I. Then the matrix is said to be orthogonal matrix. I am taking here one example having order 2 by 2. A is here cos theta, sin theta, minus sin theta and cos theta. Now we have to show that this is orthogonal matrix. Before going to check orthogonal, we have to take transpose of capital A. What is transpose of A? Interchanging of row into column. First row is here cos theta and sin theta. I am writing first column cos theta and sin theta. Second row is minus sin theta cos theta. Second column is minus sin theta cos theta. Now multiply A and A transpose. So we know already matrix multiplication. Take first row and first column, second row and second column. So cos theta into cos theta we have cos square theta, sin theta into sin theta we have sin square theta. Similarly consider first row, second column, cos theta into minus sin theta, first one plus sin theta into cos theta. And go for the second row, first column, minus sin theta cos theta plus cos theta into sin theta, and remaining minus sin theta into minus sin theta, sin square theta, cos theta into cos theta, cos square theta. Already we know cos square theta plus sin square theta value is 1. So we have standard condition, that is cos square theta plus sin square theta is equal to 1. And here plus term minus term both will cancel. We get 1 0 0 1. 1 0 0 1 is nothing but second order unit matrix, or simply we call identity matrix capital I. I is nothing but here 2 by 2 order. So if we consider A into A transpose or A transpose into A is equal to I, then A is said to be orthogonal matrix. Hope you are all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.